Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have some information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. Michiko is performing a Bernoulli trial experiment with probability of success of P, where P is distributed on the interval from 0 to 1 according to a probability distribution with density f sub P of P equal to 3P squared for P between 0 and 1 and 0 otherwise. She performs the experiment 10 times and has 2 successes. Find the mean of the posterior probability of P. So the expected value of P, given that x is equal to 2, where x is the number of successes in 10 Bernoulli trials with a probability of success P. And here's the solution. So recall that if the prior distribution of a probability P in a Bernoulli trial is beta with parameters R and S, then the posterior distribution for x equal to n, with m total Bernoulli trials, is also beta with parameters r plus n and s plus m minus n. Here, f sub p of p is 3p squared, which is 3 factorial over 2 factorial times 0 factorial times x squared, which is gamma of 3 plus 1 over gamma of 3 times gamma of 1. So it's and times x to the 3 minus 1 times 1 minus x to the 1 minus 1. For p between 0 and 1, and 0 otherwise, so that the prior distribution is beta with parameters 3 and 1, and the posterior for x equal to 2 with 10 Bernoulli trials is beta with parameters 3 plus 2 equals 5, and 1 plus 10 minus 2 equals 9. Therefore, the expected value of p, given that x is equal to 2, is 5 over 5 plus 9, which is 5 over 14. But that's the problem now. The beta distribution is not on the P1 exam anymore, so you may not have memorized the above formula. And memorization is unpleasant, but you should do it, of course, to pass the exams. So we will just calculate expected value of P, given that x is equal to 2, from its definition. We have f sub x p of xp, the joint distribution, density equal to f sub x of x, given that p is equal to p times f sub p of p. And the first expression, well, that's 10 choose x times p to the x times 1 minus p to the power 10 minus x. That's the binomial distribution, times f sub p of p, which is 3p squared. So this comes out to be 3 times 10 choose x times p to the power x plus 2, because p to the x times p squared is p to the x plus 2, times 1 minus p to the 10 minus x. Therefore, f sub p of p, given that x is equal to 2, by definition is f sub x p of 2p divided by f sub x of 2. And that's equal to 135p to the 4th times 1 minus p to the 8th over the integral from 0 to 1. Well, we calculate the marginal density from the joint density, so of 135p to the 4th times 1 minus p to the 8th dp. And 135 cancels, and what we are left with is p to the 4th times 1 minus p to the 8th over the integral from 0 to 1 of p to the 4th times 1 minus p to the 8th dp. And you can now calculate the integral in the denominator by repeated integration by parts, but that's hard, and this is simpler. Recall the beta function. Beta of rs is the integral from 0 to 1 of z to the r minus 1 times 1 minus z to the s minus 1 dz. And that actually turns out to be equal to gamma of r times gamma of s over gamma of r plus s. If you studied my study manual, you know that a real actuary remembers the gamma function. If you want to be a real actuary, you should remember everything about the gamma function. Memorize it. By the way, if you want to find a proof that this beta of rs, that integral in the middle, is actually equal to gamma of r times gamma of s over gamma of r plus s, you can look at it at my website. It's posted at smarturl.it/beta proof. Here we have r equal to 5 and s equal to 9, so that the integral from 0 to 1 of p to the 4th times 1 minus p to the 8th dp, which is beta of 5, 9, that's equal to gamma of 5 times gamma of 9 over gamma of 14. And that's equal to, well, 5 minus 1 factorial, so 4 factorial, times 9 minus 1 factorial, which is 8 factorial, divided by 14 minus 1 factorial, which is 13 factorial. And that turns out to be, after we calculate it, 1 over 6,435. And therefore, the conditional density of P, given that x is equal to 2, is 6,435 times p to the 4th times 1 minus p to the 8th. And we conclude that the expected value of that, p, and that conditional distribution, well, that's equal to p, the integral from 0 to 1 of p times this density, which is 6,435 times the integral of from 0 to 1 of p to the 5th, 1 minus p to the 8th dp. That's actually equal to 6,435 times beta of 6, 9. That ends up being equal to 5 over 14. I wrote it out in a peculiar way here. Probably complicated it too much. But anyway, that is the answer, 5 over 14, which is answer E. Although this whole writing of 9 times 10 times 11 times 13 over 2, well, that's really 9 times 5 times 11 times 13. That's a factorization of this 6435. That's my just strange way of writing it. And the reason why I did that, it was so that you can see what cancels with 14 factorial and with and that 2 will cancel with part of the 8 factorial. So that was my way of trying to cancel things out and make the calculation easier. It doesn't really matter, because if you have a calculator, you will calculate it to be 5 over 14. Please remember, this is copyrighted material. The problem was created by me and the solution is mine. All rights reserved. The reproduction in whole or in part without express written permission from the author is strictly prohibited. Well, good luck in your studies and good luck on the test.